I struggled during my secondary school days, and that experience made me able to better understand my students. I can understand their distractions and their lack of motivation. My experience has both informed and motivated me to help those who are struggling to navigate through similar academic situations. I have certainly encountered lecturers throughout my studies and career who have provided me with the extra guidance when I need it. I hope students and parents can see a type of school like IT as a bridge to higher education. Students who find themselves more academically inclined have a pathway to progress at IT towards obtaining a diploma. We use AR technology to teach our students. During our Makeathon events, students can see their skill sets are being used to make prototypes and win awards. This gives them encouragement to pursue engineering as a career. One Makeathon project is the Feel-Safe wheelchair. The design of the Feel-Safe wheelchair is derived from the concept of an airport trolley. The brake is automatically engaged when the wheelchair is unattended. This prevents the wheelchair occupants from rolling down a slope in the event that caregiver leave the wheelchair unattended and without the brakes on. The Smart Walking Cane. It looks like a normal walking cane, but it features an incorporated wet floor sensor. The sensors together with microcontroller activates the beeping buzzer and the vibration motor when the sensors located at the rubber foot touches a wet surface. This alerts the user that the floor is wet and discourages the user to continue walking. This smart walking stick adds safe functionality to the normal walking stick. We have donated about 20 canes to Society of Aged Sick and St. Luke Nursing Home. Fusion 360 allows students to draft their design and use the software to illustrate their ideas and inform their discussions. Fusion 360 can be easily downloaded to a student's personal laptop and it is user-friendly. Our students knowing Autodesk products give them an edge in terms of future employment. To be a leader in manufacturing education, one has to keep updated with industry needs and standards. It is essential that one trains students to have the latest skill sets which help them progress in their career. We connect with industry with facility visits, seminars, and attending professional development courses and outreach programs. I think Autodesk play a role in fostering and facilitating our connection with industry. Some of our students are already connected to EIA companies that use Autodesk. My advice to students is to never stop learning.
From the smallest components to the largest assemblies, Autodesk Inventor is the 3D CAD software you need for everyday projects and ambitious challenges. Inventor puts powerful mechanical design, documentation, and product simulation tools at your fingertips to help you innovate with agility, collaborate effectively, and win more business. Inventor provides you with a stable and responsive environment to help you get your projects to production faster. With a complete set of tools for sheet metal, welded frames, tube and pipe, and electromechanical, and direct access to a robust content library and engineering calculators. Shave days off your projects by rapidly configuring products using iLogic design automation technology. Speed up design reviews with a cloud-based tool that protects your intellectual property. Connect directly with AutoCAD for your project workflows. And you can extend the power of Inventor with a subscription to the Product Design and Manufacturing Collection to take your designs further with 2D and 3D workflows, cloud-based design and manufacturing, factory planning, and high-end visualization. Regardless of what you make, industrial machines, conveyor systems, or top fuel dragsters, solve your most interesting problems efficiently and effectively with Autodesk Inventor.
Okay, good afternoon everyone, and welcome to our part 2 for Autodesk Inventor Essentials training. So this training is actually one of the benefit to all who have registered for our upcoming SolidWorks training. So it's hitting two birds with one stone. You get to be learning Inventor and you get to be learning SolidWorks as well. So all through very small price of registration. Okay, so yep. So also for those who are our paid participants, of course, definitely you'll be receiving an Autodesk certificate of course completion. Yan. So what I'm showing you here is a sample of that certificate. Okay, so sharing the registration link. So this is actually the registration link. SolidWorks training.digitalcreativeslearning.com. So register now. Okay. In addition to that, if you are into architecture, engineering, and construction, inviting you to join us in BIM Philippines. So BIM, Building Information Modeling. So inviting you here if you're interested or you would like to be or to have a career in the AEC industry. Inviting you to join us in BIM Philippines. And of course, we have our Autodesk Inventor group. Inviting you to join us here as well. It's facebook.com/groups/Autodesk Inventor.
A simple project that would have taken 4 hours, we can now do in 20 minutes. And a complex project that would have taken 2 days, we can do in 2 or 3 hours.
We design, manufacture, deliver, and install custom staircases. Every system is new for that customer, so every system is at least a 1/16 of an inch different. We're often one of the last products that gets installed in a home, and if we don't get it right, we can delay them getting a certificate of occupancy. Without iLogic, it took quite a bit to draw even the simplest of orders.
It was very disheartening how much manual labor went into it.
We could draw maybe one order a day. We turned to the Autodesk Product Design and Manufacturing Collection. Autodesk Inventor and iLogic has allowed us to automate the engineering or project management process.
A lot of things in stair design are repetitive tasks, and iLogic enables us to automate a lot of those so that a human operator doesn't have to get lost in the minutia.
So let's say, we decided to pull a foot off of that floor, we added a wall there. I would come in and modify the environment here, tell it for length, put in either an absolute, or in this case, if they said we'd subtracted 10 inches, I'd do it. And I would just tell it to update all my glass. It's going to automatically engineer it for me. It's going to make it so that it meets all building codes that our product is certified for, and it's going to generate shop drawings and production prints for these as it goes. It's that easy.
We're manufacturing 10 systems, 20 systems a day right now. With the Inventor CAM, we take the exact model that is part of our automation that we've used to design for the customer, and it's already toolpathed. So that production engineer is just posting that right to the machine. It's a huge time savings, and it's a quality assurance. As we build in more and more automation, we continue to drive down the potential errors that a user can make.
Welcome to Bureau.
Thank you.
Have a seat.
We leverage the Forge viewer. It enables the customer to view on a web page on their phone exactly what we are engineering and how it will fit into their space.
This looks amazing.
We are now over 10 times the size that we were when we started all of the automation.
Then in the next 5 years, we're going to grow from $100 million a year in revenue to $500 million. Automation is critical for scaling at the rate that we're going. We would not be able to do the things that we are doing today and looking into the future without the Autodesk tools.
Okay, so notice last time we have this activity, a challenge for our sketching. Okay, so I want you to recall this activity last time, so feel free to screen capture this challenge. So again, our goal is to create the sketch for this assembly, okay, similar to this. So notice this is inside sketch 1. So all of these target parts are in sketch 1. Okay, so now let me demonstrate on how to do this sketch. Okay, so definitely in this exercise will be challenged, okay, to quickly learn and apply what those constraints are. So I'm going to go to front view, zooming in, and I'm going to activate sketch 1. So hovering over sketch 1, I can right click and select edit sketch. So notice I can move these entities by left clicking and holding, because these are not yet fully constrained. Okay, so going back to our activity, I am seeing this square has 60 in dimension. So I'm going to hit D, the shortcut for dimension. Let's dimension this out as this one to be 60. Again, this one to be 60 as well. Okay, so this one to be 24. What else? So both are 24. So selecting this horizontal line, this horizontal line. So notice this is currently highlighted in blue. I can select, while this is highlighted in blue, this units, this values, I'm going to hover over 24. Notice there's an FX letters there. I'm going to left click. So what happened here is that dimension ID D3 now inherited the dimension of D2, which has a value of 24. So selecting OK or hitting the green check mark. So if I have this as 20, definitely this will adjust to 20 as well. So double left click to revise or update this dimension. Next. What else? I'm seeing this as 6, right? Hitting enter. Next, I feel it would be much better if I just mirror this entity out to the left side. So to do that, of course, we need to create a mirror line for us to do that. Okay, but first, let me target this area. What's the dimension for this? So this one is 20. Right? So this one as well is 50. The angle between 50. Same here. 50. So repeating what we did a while ago with regards to parameters, fx, that fx with D7 dimension highlighted, this value is highlighted in blue. I'm going to left click on 50. Next, I'm going to drag this as well. And I'm going to align the midpoint and the midpoint of this horizontal line vertically. So I'm going to head up, selecting vertical constraint. So this is the midpoint for this line and selecting the midpoint for this line. So both are now aligned. Let me check. So I'm holding my left mouse button and moving these entities. So from here, I know what's lacking now is the dimension for T. So hitting D, selecting this point and this point, typing in 40. So let me move. It cannot move anymore, which means it's fully constrained. Same with this. Okay, so I'm going to create a window selection now and delete this rectangle. Next, I'm going to hit line. I'm going to create a line which will serve as our mirror line. So left click here and double left click. Left click here and double left click. Now I'm going to select these two lines and convert them into a construction line. Actually, up above on our ribbon, it's construction on the upper right. If you're seeing this in the upper right. So another method is I can right click and select construction. So selecting construction. Next, I'm going to create a window selection for this. And under pattern, I'm going to select mirror. So again, selecting these entities, the mirror line to be this construction line. And selecting apply. Selecting done. So let's repeat the procedure. I'm going to select mirror. So selecting the items or entities, I'm going to create a window selection, making sure this rectangle is inside that window. Release, activating mirror line, selecting this vertical construction line, and selecting apply. Okay, so selecting done. So from black, it's now blue in color. Okay, next. How about creating this part? So hitting D. Okay, the diameter for this, it's 24. So typing in 24. Going to create a window selection and move this. Okay, move this lines. So next, I'm going to apply the method we did with regards to vertical constraint. So up above under constraint, we're going to align vertically the midpoints of this horizontal line and this horizontal line. Okay. Next, let's define the diameter for this. Indicated in the drawing, it's actually 12. Okay, so I can actually move this somewhere here so it won't bother us. Next, this one to be 20. 20. What else? Okay, so the whole length. So notice if I left click and hold, by seeing the movement of entities, I am seeing what constraint is needed. So here, to prevent this from going up and down, definitely we need to key in that 100 dimension. So selecting this line, left click here to place our dimension and key in 100. And from here, I can create a window selection and move this somewhere here. So I feel that this one is now affected. Oh, not yet. Not pala. Okay. So let's now recreate the sketch for this entity. Okay. So what I'm seeing, this has a dimension of 24. But first, I'm going to offset this, my preference, offsetting that. Hitting D for dimension, radius. I'm going to define this as 36. And same with this one to be 24. Also, I'm going to be creating lines somewhere here. So left click, double left click to end that chain of lines. So this is defined as 24. Okay. Hitting escape. Next, I'm going to have this coinciding with this arc. So selecting coincident, this line terminating this arc, this line, this endpoint. Again, this endpoint to this arc. Okay, so nudging these points, pulling them. Next, notice the center point of this arc. So I'm going to align the center point of this arc with the midpoint of this horizontal line. So again, going back to vertical constraint, selecting to midpoint and this center point. Okay, and I'm seeing as well this center point should be coincident with the midpoint. So let's select coincident, selecting midpoint and this, selecting the center point and this midpoint. I'm going to pull this up. Same here. And I'm seeing a fillet. So I'm going to select an arc. Let's create an arc here. So notice that symbol as I place my cursor here. That's the tangent symbol. Left click. Now those fillets has a radius of 4. So hitting D, typing in 4. Pulling this down. Next, I'm going to hit L for line. Let's create a line, vertical, all the way here, going up to here. Okay. Next, the dimension for this is 16, hitting D, 16. Selecting this line and this line, keying in 16. Or moving this dimension over here. Next, I am seeing this point should be aligned horizontally with this point. So I'm going to head over to horizontal constraint, selecting this point and this point. Next, let's remove this arc. So I'm going to head up to modify, selecting trim. Let's trim this out. Also, again, there's a fillet here. So I can select fillet under create. fillet, selecting this arc and this line. Now, the value to be 4. So again, this line and this line. Hitting enter. Or I can double left click this dimension and simply select this dimension as well. So whenever D16, the dimension ID for this arc, so whenever we change the value of this, automatically it will update the dimension of D18. So same with what we did a while ago, selecting fillet, selecting this line and this arc. Okay, double left click here to revise the unit or the value of this dimension, selecting this dimension, D16, hitting enter. So in addition to that, definitely because we have a vertical construction line, we can mirror these entities to the left side. So let's do that. Heading over to mirror. Now for the mirror item, selecting this arc, this line, and this line. Activating mirror line, left click. The mirror line to be this vertical line, selecting apply. Hitting escape. Let me move this dimension over here. And of course, we need these 2 points to coincide with each other. So let me head up to constraint, selecting coincident, selecting this point and this point. And just to make sure, I'm going to select tangent, selecting this arc and this arc. So they are now both tangent. And definitely this point should be touching or coinciding with this line. So selecting coincident, selecting this point and this line, this point and this line. Okay, so inspecting moving entities to check if this is not yet fully constrained or defined. So this one, obviously not yet fully defined. So what I am seeing here is we may probably align this center point to this point vertically. So going to the right side, I'm going to select vertical, selecting this point and this point. So everything now is in blue, which means fully defined. I'm seeing this as black. So definitely this one requiring a dimension. And based on our exercise, the dimension should be from here all the way here to be 80. Hitting enter. Okay, so I can fully define this peg or the shaft that will go here. But for now, I'm going to leave this out. Okay. So I want you again to recreate what I did. And on our third meeting, which is the topic of creating assemblies, definitely we will turn this into a dynamic assembly. Okay, but for now, relating this to our first session, which is all about sketches and constraints, I'm showing you how we can create an assembly through a mere one piece of sketch. So again, these are all made into sketch 1. Okay, so from here, I can select finish. Okay, I can select E for extrude. Okay, I can select this profile. For the direction, I'm going to select symmetric. And its value to be 100. Hitting enter. I'm going to expand extrusion 1. Right click. Okay. And turn on the visibility of sketch 1. And actually, based on that extrusion, we have created a solid body. It's registered here as solid 1. So I'm going to head over to solid 1, right click, and turn off its visibility. Turning this off. Hitting E again for extrude. This time selecting this profiles. So again, for the behavior direction, I want this to be symmetric. And for its thickness, it's defined as 20. So let me check. Edit sketch. Okay, this is actually the extrusion. Edit feature. So I want its Boolean operation. So take note, the Boolean operation with extrusion or solid 1 turned off. We prefer the Boolean operation to be new solid. Okay, so notice as I hit OK and turn on the visibility of solid 1, we now have 2 bodies. So take note, this is just one part, a part having multi-bodies. Okay, so let me again turn off the visibility of these bodies. Right click, turning off its visibility. And next, definitely, this shaft. So to create this feature, this should be a revolved feature. So, and for revolve, we need an axis. So I'm going to head over again to our main sketch, right click, selecting edit sketch. So right click, edit sketch. Going to create a line from this midpoint all the way down to this midpoint. Selecting finish. Next, let's select revolve. And for the profiles, I'm going to select this profiles. And for its axis, I'm going to select this vertical line. Okay, so checking again. And for the Boolean operation, it's new solid. And selecting OK. So from here, I'm going to go back to our solid 1. Show its visibility together with solid 2. Enable its visibility. Okay, so I want you to set this aside and save. And on our third meeting, as we discover assemblies, we will turn this into multi-parts, because definitely this is currently a single part having multiple bodies. So I'm going to hit save for this. Okay, so shout out to Onesimus Nukurunungi. Thank you for joining us. So again, for those who would like to receive a certificate from certificate of course completion from Autodesk. Please register. You may register to this link, solidworkstraining.digitalcreativeslearning.com. Okay, so for our next activity, I would like to challenge you in creating this part. Okay, I want you to create this part. So definitely this is a simple basic part that will definitely consist of more than 2 sketches. So please screen capture this part. Also, let me call in our technical support, Miss Melge. Miss Melge. Calling Miss Melge. So, in addition to that, all of our paid participants, please enroll them to this course that will help them master out part modeling in Inventor. So this course is free to all of our registered paid participants. So let me share the link to this course. So again, by registering in our SolidWorks training, definitely this is an added value. Not only will you be able to learn SolidWorks, but also Inventor as well. Okay, so showing you the link to register. Again, so let me show you the activity once more. Okay, so let me now do that challenge, my turn. So I'm going to hit Control N. and twirl down. So let us assume that this challenge is in English and in inches. So I'm going to select standard part inch.ipt, double left click. Hitting F6 for isometric view. Hitting S for sketch. So for this, my interpretation is I'm going to create a sketch on the XY plane. Next, I'm going to hit L for line and quickly create this sketch. Double left click. So obviously this line needs to be perfectly vertical. So selecting this line, I'm going to have this, or select vertical constraint, and probably this is now perfectly horizontal. So it is. Okay. Next, I'm going to hit D for dimension, selecting this line and this line. Left click here to place that angle, that dimension. So keying in 60. Same with this line and this point to be 3.5. Let me zoom out, hit D, this one and this one to be 1.75. Hitting escape. So checking. So this is now fully defined. Let's now hit E for extrude. So again, notice the preference is always having the coordinates, the 0, 0, 0, X, Y, Z, 0, to be always at the center or middle. That's why, as much as we can, if it's symmetrical, we select symmetric for the behavior. So this one is 2. Hitting enter. So next, we need to create a cut extrusion for this part. So I'm going to revolve this. I prefer sketching on this side. Okay, selecting this face, hit S for sketch. Next, I'm going to select rectangle and create a rectangle here. Next, hit D for dimension. I am seeing the 1.25, selecting this edge and this line, 1.25, and we have the 0.5 on this side. So 0.5, selecting this edge, this line, left click here to place our dimension. And repeating what we did a while ago for making things equal. Actually, I can commit to this value. So notice the difference between the two. I can head over to constraint, select equal. But of course, this all only applies to something that is an entity. So not dimension. So again, I'm going to double left click 0.465 or dimension D7 and left click on this dimension, which is D6. Selecting the green check mark and selecting finish. We now have the profile for our cut extrusion. So hitting E, I'm going to pull this arrow to the left, making a cut extrusion. Okay, and I prefer the distance to be through all. And hit OK. So that's how we have quickly created this part modeling challenge. Okay, so again, we'll be giving you access to this course, which has, I think, more than minimum 10 of part modeling challenges for you to master part modeling, and linking that to the importance of sketches and constraints. Okay, so next, the next challenge, I want you to create this challenge. So feel free to screen capture this. Next challenge. So again, guys, feel free to screen capture this next challenge. Okay, so let's now do this challenge. So for that one, I'm going to hit Control N again. And this time for the template, selecting metric, selecting standard millimeter.ipt. So double left click. I prefer always hitting the F6 for isometric view. And I'm going to hit R or simply S to go to sketch mode right away. So I'm going to hit or to select the XZ plane and rotate the view. So notice here beside our view cube, rotating this counterclockwise. And I'm seeing the dimensions are referring actually to the left corner of this part modeling challenge. So with that, I'm going to select rectangle. I'm going to quickly create a rectangle here, a rectangle here, and a rectangle here. Or of course, you may of course create a series of lines like this one, right? Okay, you can also create that series of lines and then apply constraints. So I prefer this one just to be quick. So next, I'm going to select this line. So based on what I am seeing from the behavior, this is currently now collinear. These two lines are now collinear with each other. So hitting D for dimension. Let's define this to be 15. This to be 20. Next, this to be 30. And for A, from here to here, it's 110. From this line up to this line, this one should be 50, named as C, dimension C. So it's now in dark blue color, which denotes this is now fully constrained. Let's now select finish. Hit E for extrude, selecting this profiles. And I'm seeing B having a dimension or value of 60. Keying in 60, extruding this upwards. Okay, selecting this. Next, there's a taper here on this side. So my take on that is I'm going to create a sketch here. Hit S and create a diagonal line coming from this edge all the way to this vertical edge. So checking if this is in with the coincident constraint. So that one has, and this one doesn't have. So let's head up to constraint, selecting this point and this vertical edge. Let's now apply dimension, hitting D, selecting this point and this edge. So defined there as 30. Same with this point, this edge to be 20. We're done. And this is now in dark blue, which is fully defined. Selecting finish, selecting E for extrude. And let's make this as a cut extrusion. I prefer through all for the distance. Okay. Selecting this. Hit F6. And same procedure with the feature here, or you may also, of course, create a chamfer. But for me, I prefer recreating that technique we did a while ago. So selecting this face, hitting S, and creating another line here. Left click, double left click. So checking. Hit D for dimension. It's 30 from that point to this edge. And 10 for this edge and this point. Keying in 10. Hit E for extrude. Pulling this to the left. And this time, instead of through all, I want that extrusion to be always up to this face. Selecting OK. And we have now created our third challenge. So, hoping this gets you off your feet, and hoping this challenges you to create our next batch of challenges. So I want you to screen capture this, challenging you to recreate this part model, this simple part model. Okay, so please screen capture this part model, and I want you to recreate as well our next challenge. Create this as well. Okay, screen capture that, recreate that challenge. And recreate this challenge. And I'm thinking this as well. I want you to recreate this as well for our, if we still have the time, we may do a rendering. We may touch on rendering. So recreate this camera as well. And for this camera, feel free to add extra features to make this more believable. Okay, so for this camera, feel free to add features, additional details. So this one will be used for our rendering session as we discover how to render in Autodesk Inventor. Okay, so yep, congratulations. If you're still in this training session, thank you so much. And again, I hope you have screen captured your assignments, your homeworks, the challenges. And of course, this live stream is being recorded in our YouTube channel. So you may head over to youtube.com/MechaniWeb for the replay of this session. Okay? So again, for those who have completed, will be completing, and have submitted the activities, you'll get a chance to receive an Autodesk certificate of course completion. So once more, thank you so much. Thank you everyone, and see you again. I hope to see your works submitted. And yeah, on our third session, hoping I get to be with you once more as we discover how to create dynamic assemblies. So thank you so much everyone. Good afternoon.
From the smallest components to the largest assemblies, Autodesk Inventor is the 3D CAD software you need for everyday projects and ambitious challenges. Inventor puts powerful mechanical design, documentation, and product simulation tools at your fingertips to help you innovate with agility, collaborate effectively, and win more business. Inventor provides you with a stable and responsive environment to help you get your projects to production faster. With a complete set of tools for sheet metal, welded frames, tube and pipe, and electromechanical, and direct access to a robust content library and engineering calculators. Shave days off your projects by rapidly configuring products using iLogic design automation technology. speed up design reviews with a cloud-based tool that protects your intellectual property. Connect directly with AutoCAD for your project workflows. And you can extend the power of Inventor with a subscription to the Product Design and Manufacturing Collection to take your designs further with 2D and 3D workflows, cloud-based design and manufacturing, factory planning, and high-end visualization. Regardless of what you make, industrial machines, conveyor systems, or top fuel dragsters, solve your most interesting problems efficiently and effectively with Autodesk Inventor.
These cars are so violent. It's amazing how much damage we can do in 3.5 seconds.
You're going to win or lose by merely inches, thousandths, 10,000ths of a second.
Everything has to be built right. Everybody has to be on their game.
Hopefully you're on the other side of that, and you get the W.
Collada Motorsports is a professional drag racing team. We compete at 24 events across the country.
We use the Product Design and Manufacturing Collection from Autodesk. It makes our job so much easier. Not having to use multiple software packages saves us a ton of time. So Inventor is helpful because it's tied in with everything. You do all your modeling, you do your drawings. When you update in the model, it updates the CAM. So these cars go over 330 miles an hour and they travel 1,000 feet in less than 3.5 seconds. To accomplish something like that is really tough on the parts.
This is not a business where you can make a ton of mistakes.
If we don't do our job down to the smallest detail, that driver's life is in our hands. Everything has to be built right. Everybody has to be on their game.
Welcome to Charlotte's Z-Max Dragway for the 4-Wide Nationals. Got some great
safety is number one, and then second would be performance. We need to make sure our equipment's strong enough and light enough where we can outperform our opponents.
Currently, they're finishing up the track prep. We've got top fuel dragsters up next for you.
At the 4-Wide Nationals, we had the Autodesk on Doug Coletta's top fuel dragster. My expectation is to win every race we go to.
In lane 2, we have Doug Coletta with the Autodesk car.
So Inventor is helpful because races in our league can be decided by 1,000ths of a second. So if we find something on a part to make it a little bit stronger, a little bit lighter, or a little bit better than what everybody else has, that makes us a big part of winning races.
Coletta crossing the finish line first, clocking in over 330 miles per hour.
Seeing something get made and then get put on the race car and us going out and running over 300 miles an hour, that's pretty neat to see.